I wanted to walk everybody through the code base for the Discord bot that you were interacting with this morning. So as a reminder, that's the askFSDL bot channel in the Discord. And yeah, so it's sort of a bit more mature version of what I walked through building this morning. So just sourced question answering over a corpus of information using vector storage for retrieval. And so there's a GitHub repo for this project. I posted the link in the Discord as well. So if you want to follow along, look at some of the code yourself. There's a bunch of moving pieces to set up, a document database and an account on Modal. So I doubt you'll be able to execute the code unless you happen to have accounts on every single service that we're using. But you can at least check the code out and follow along. And also still encourage people to ask questions in the Q&A channel for any questions that they have. So, all right, let's dive in. So what are some of the primary things that you need to improve as you're going forward? So there's some basic stuff that's just generic Python project management things. So for example, actually let me drop into VS Code here. So one nice little feature that we like to do at FSDL with a lot of our projects is you make a nice little make file for all the components of the project with a nice little help message. So this is all the different pieces, and the make file can sort of set up and run a bunch of these things. So set up Discord bot, deploy the backend, set up a vector index, all that good stuff. So that's where you'll want to go if you want to see what are the run the setup commands. So it's got things like the environment and setting up authentication with a bunch of our tools. So then other things that you might want in a project, we were just kind of YOLOing code in the morning in Jupyter Notebooks and other places. There's in this project, we've got a bunch of nice software tools. So one of the main ones is precommits for GitHub. So this is just a code cleanliness thing. If you're doing software engineering, you want to make sure that when a team's collaborating on a code base, that people are good stewards of the code. And so pre-commit checks every time somebody's about to commit something to GitHub. You can just run some checks on it to make sure that they haven't made any common mistakes, added extra white space, messed up the syntax of common files, forgot that they were in a merge, added large files, lots of little simple ones, and then also a bunch of other code quality things. We like to use Black for Python auto formatting to make sure formats of Python files all look the same. We've recently switched over in past iterations of the course. We've used the tool Flake 8 for linting, for sort of catching sort of simple stylistic errors and style conventions. Rough came out just in the last 6 or 9 months, became a lot more popular. Rust-powered formatter for Python that's really quite nice. And yeah, let's just run that real quick, check to make sure I haven't messed anything up. So yeah, these kinds of tools. There's one more that I wanted to quickly shout out, which is this shell check tool. If you find yourself writing a lot of bash scripts, copy to redis.sh or whatever, and you find yourself Googling or going to ChatGPT to check things, shell check is really nice for catching those dumb things about arrays and if statements and other things that bedevil bash scripting. Yeah, so some basic little software engineering things. There's also a bunch of stuff. This is the sort of thing that you need to support any sort of software engineering project. using Python, you need this kind of tooling. What about things that made this project in particular better? So I'm jumping around all over the place, but what I wanted to show you was the data processing step. So one of the first things that we realized when we did the bare minimum version of this, it looked a lot like what I did in the morning, which is just like scrape data and like chunk it up into little pieces, and like those are the sources that you're going to use. And that turns out to like not work super well. It doesn't give really good results for people. And so what we found was that we got the biggest improvements in the quality of the results by spending time with our data. So there's a little Jupyter notebook that walks through some of the things that we did to improve our data, and this also happens to set up the overall like document database as well. So you can see how that's done. You can bring your own like MongoDB database. We used the like Atlas hosted platform. So just to give you an example of the kinds of things that turn out to be like critically important. So in addition to the like PDF files that we talked about this morning, we also pulled a lot of stuff from the like full stack deep learning website, where we host a bunch of like notes about our lectures and like other kinds of things. And if you just like treat it as text and parse it as text, you lose all of the structure that's in that structured text, that's in the features of the markdown. So it's got things like section headers. It's got separate like paragraphs. There's like a lot of richness there. And in a lot of cases, those end up being like links to specific components of pages. And the goal of this was provide sources to help people quickly find information. And so being able to like preserve that structure when you're bringing in the documents turned out to be pretty important. So this requires like a little bit of knowledge of like the data that you're scraping. So it's maybe like if you're scraping internet scale stuff, this is going to be a lot more challenging. But if you're building something that's like oriented to like Q&A over your company's knowledge store, then maybe you have a little bit more context that can do these things. Improving the like automated processing of text is definitely something that large language models will hopefully will be able to do in the next couple of years. So it's a matter of like searching around, finding the right kind of like Python libraries for solving these kinds of problems without you having to write a bunch of hard to maintain code yourself. So all this splitting, the goal there is to just get some like basic format of these documents that preserves the information needed to link to them and preserves as much of the structure as possible. So this is distinct from what you might also see people doing with tools like LangChain and things integrated with it, which is chunking stuff up to put it in a vector store. That's a matter of making sure something is small enough to fit into the context of a language model, as opposed to like just parsing a document and like preserving its structure while you're storing it. Then the other thing is that like in the morning we talked about like having to load PDFs, and PDFs are kind of an image format in a lot of ways rather than text, but it's plausible that you can just get the text out of a PDF. But that's not like the only thing that you can potentially index. There are lots of ways to automatically extract textual information from other kinds of sources. So you can pass images into an image to text model, the sort of reverse of something like DALL-E or Midjourney, something that takes in an image and returns a description of its content. The thing that we focused on was our YouTube videos. So we put videos of our content online. Those videos get transcripts actually for free from YouTube. And we can then use those transcripts as sources for the question answering bot. So finding creative ways to extract data from your knowledge bases and make them accessible to LLMs via embeddings or via other ways of like connecting them up with the language model is like I think a big open field for ways to make more useful language model applications. So this spent a good chunk of time trying to figure out how to use the YouTube SDK before realizing there's just one Python library that'll do it for you, YouTube Transcript API, which you love to see. We can only hope that the number of dumb little Python libraries that solve one little task goes up over time with language models. But even when you have like pretty good access to like quickly get a hold of data, that's often some kind of scrape that's not taking your particular problem into account. So the problem that I ran into with the YouTube videos was that all of the tags, there were timing tags, which is awesome. Timing tags can be used to like link to a YouTube video. You can link to a specific moment in the video. And that's awesome for this sourcing application because I can just bring them exactly to the point in the video where their question is answered. But the subtitles are time tags for like 1 second at a time because that's used to put them, layer them on top of the video. So there's a pretty simple fix, which is just to go in and chunk it into a size that like contains a useful amount of information or like has about a couple thousand tokens or a couple hundred tokens worth of text in it. So it's a relatively simple solution, but these are the kinds of things that unless you're thinking about a particular data source, the particular problem you're trying to solve, then like you won't think to do them. So that was like a big increase in the quality of the results here. I think for myself personally, one of the things I found this most useful for is like finding components of our videos where it's like, I know that I talked about this at some point and just ask FSDL bot and then it pulls me directly to the link. So like there's big dividends that come to this kind of like grunt work or this like unglamorous work of like getting to know the data and like writing the dumb little code to manage it properly. So that's the main thing I wanted to talk about in this notebook. It goes into a little bit more, like there's a little bit of stuff there about how we get it into the document store, but that's a little bit less interesting. Are we getting any questions in that Q&A channel?
There's a question about, can you talk more about how you're using Modal and why?
Yeah, that would be, that's suspiciously close to my next planned topic. Okay. But are there any other questions before I do that?
Actually, there aren't yet, unless my internet's slow.
Yeah, could be it. Let's do that then. We got. So maybe, real quick. I want to also just pull up that architecture diagram because as dumb as architecture diagrams are, they're really helpful for like keeping it all in your head.
People are asking, are you going to share the notebook?
Yeah, the notebook is there's a link to that GitHub repo in the Discord, and that has that notebook in it. Yeah. Okay. So what were we just talking about? We were just talking about the kind of like ETL component of this, which is like, how do I extract information from places where it's located out there on the web or in my like the general data storage of my organization? How do I transform it into the format that is most useful? And then how do I load that into some like specific storage for that specific transformed data? So that's the top left corner there. For a lot of stuff, I showed all that stuff happening in the Jupyter Notebook, but it's the sort of thing that you might want to use a tool like Modal for. So Modal, like you may have noticed, like I was just like grabbing random Python packages and using them for stuff. And the nice thing about that is it brings like the code that you need for the particular problem you're trying to solve. But once you start installing like 50 or 60 dumb little Python packages, all of a sudden it's like they disagree about which version of some like 7th order transitive dependency, and now they no longer work. And yeah, specifically the Python dev tooling stack is particularly bad about that, which is a great reason to use that precommit tool that kind of isolates the environments and makes sure that you aren't like, Black and Flake 8 have incompatible versions of some, there's a particular example that was really bad and broke a bunch of installs like 9 months ago. So so there's a bunch of things that are solved by the like modal component of this application, but one of them is that you can actually separate out different container images for like each thing that you want to do. So to clarify what that means is you're basically like creating a lightweight virtual machine that runs in Modal's cloud for each task that you want to solve. So I didn't do as much breaking down of the modal images as I would like to do in this particular example, but that's one of the core benefits. You define one of these images here, a modal image. You pick some base version, and then you customize it. So this is all pip installs, but you can do all kinds of other things. Many of the things, if you're familiar with making Docker containers yourself, then it's like a lot of the things you might expect, like mounting things, installing Linux packages, running shell commands, etc. And one big reason why I really love Modal, like 6 months ago or so, I started looking into options, and this is the one that I ended up sticking with, is that it's actually not literally a Docker image. It is an open container image compliant implementation. And it's like incredibly fast. And that means that a lot of the pain that you might have experienced if you've used another like similar tool for cloud native development goes away. So maybe just like some quick evidence of that would be to just do the debugger. Yeah. So just as an example, things are often quite slow. Like creating containers can be slow, pushing container images around can be slow. You end up introducing a bunch of friction that then reduces the actual benefit to your deployment speed. So with this, with Modal, the speed is quite good, and there's a lot of like nice little features added that like help make sure your development cycles stay really fast. So this example here is supported by just like one little block of code down here. I'm like writing this little function that imports IPython and then spins up an IPython kernel. So this is actually now one of my preferred ways to do debugging even locally. But I discovered it as the suggested way to debug stuff on Modal. It includes the context of your of the things that you are running in the cloud infrastructure, because it's running there, but it's like nearly as fast and nearly as convenient as running like a kernel, running like an IPython setup locally. So I think there should be I forget which things I implemented for the in an hour version versus in this version. So I think that autocomplete maybe isn't working. Yeah, there we go. Okay. So I can run things. What is GPT-4? Yeah. Yeah. So all this, so that function right there, this Q&A LangChain, this is something that is like something that runs in my backend. It runs in an environment that's like not something that I want to try and replicate locally, that I don't want to keep in line, but I can run it a little bit like as though I were like developing locally by just like connecting to a container that's running on Modal and doing it in interactive mode. So main pain points that are going away. Yeah, so in the morning I talked about how it was like, oh yeah, launch 100 containers at once, run them on like all your little tasks collected up. So that's obviously an accelerator. We talked about the ability to spin up specific environments, avoid those things. Oh, and then in addition to all this, like the goal of it isn't just like a data engineering platform or anything like that. It's also got this, it's also designed to like end up with applications. So it's got things built into it like asynchronous server gateway interfaces as endpoints that are just like very, very well designed abstractions that you can like wrap on top of the stuff that you're building and end up with an application like the one that y'all have been interacting with. And just to see like you get a decent interface into it, like I can check this, I can check the application and see activity. I can get like a lot more detail. like you can attach GPUs if you want, and then you can track things like utilization, and then all this is done serverlessly. So whenever you like need compute, you get a hold of it, and then when you don't need it, it goes away. And so since a lot of stuff right now is in this very tinkering phase, where you're like, maybe you only have users for like 20 minutes in the morning, right when you're showing them your application, and then you have no users for the rest of the day. It would be a shame to like have to spin up a bunch of servers in order to handle those requests and then leave them on while nobody's talking to you. And so this like spinning up and spinning down auto scaling is built into Modal and works, in my experience, like pretty well. Definitely challenging if you're like loading a machine learning model, putting it on the GPU and serving a request. That's a pretty challenging application of serverless. Modal does an okay job at it in my experience. The other piece added that I wanted to call out that was added to this and is generally useful is a Gradio user interface. So Gradio, I'm scrolling down for this page. So there's our, this is our, like, the Modal ASCII app. We got that. And this Gradio is the tool that means that I don't actually have to learn JavaScript already. It's like, since then, also ChatGPT has meant that I don't have to learn JavaScript. But what it provides for you primarily is that you can describe an interface, like a user interface in pure Python, and then end up with like a kind of simple, like single or few page application that has that interface in it. And it's like surprisingly flexible. It's like, it's supported by Hugging Face, and so they like rapidly add all of the features that you would want as somebody building with machine learning. So here's an example. This also happens to be the interface that has been used by like Alpaca and I think Flamingo as the way that they demonstrate their models. They use like a little Gradio app. Dolly Mini was originally a Gradio app, so it's a great way to like get started really quickly. And yeah, that was just a little serverless cold boot right there. I just hit refresh. Took a few seconds. So if you're worried about your P99s, you might want to do something like keep some things alive at all times. But yeah, this interface, I describe it entirely in Python. It interacts with stuff that is primarily in Python, so LangChain, and like maybe I'm like doing stuff with my embedding vectors. Maybe I'm running my own models. A lot of that stuff is going to be in Python, and I can play around with it here. And I like to do this. It's so easy to spin one of these things up that I like to do it as something that, like, let's say I like run a training run for a model. I might just like spin up a UI for it, like for that specific version of that model, so that I can go back to it and be like, wait, when did this weird behavior get introduced in my models? Was it in this one, or was it in like, was it 3 months ago, or was it 1 month ago? Yeah, so I can check my language model's behavior on important questions like, would you rather fight 100 llama-sized GPT-4s or one GPT-4-sized llama? I can go back and use this example and check it on all kinds of different models if I do that. Great. So yeah, so Gradio, quick UIs, both for like demos and also for like other places where a UI would be great, but you don't want to take the time to spin it up. You can embed them as, you can run them in Jupyter Notebooks. You can like embed them as iframes. They're like very portable and flexible. And they come with an API with an open API spec. I believe always an open API spec. And so like you can hook up into a bunch of different tooling. These are like getting hooked up into things like ChatGPT plugins via the like open API. And it comes with a client SDK for like for everything that you make. Like you don't just have to interact with stuff via like requests and HTTP. So now we've got, oh, check it out. Like I have this client SDK for running my Q&A, the sources. Okay. Any questions in the Discord?
How did you actually hook up Discord to this?
Oh yeah, that was kind of like the least interesting part, but I can show that. So Discord, there's of course a Python library for running Discord bots. It's called just so Discord Pi was the one that I ran with. I've actually heard from other people that there's one called Interactions that's a little bit better, so you might want to try that one instead. But this one was perfectly fine. Looking back on it, Discord is not the easiest interface to run stuff with. There's a lot of like precise, like very fiddly details. For example, they're not actually called like forums or groups or servers. They're called guilds, dating back to when Discord was for organizing WoW raids. And so there's just like a bunch of, it's a weird interface. But there's some nice stuff. Like it was one of my first it was a good experience with like async Python for like being able to handle more requests. But yeah, it's like very simple to add these like commands, and then you get this nice user interface. So I shouldn't talk too much bad about it. But you just define these events, and I think maybe the more interesting thing, or maybe the question the person was really asking, is less about like what does it look like to run this Discord bot, and more like what does how does the Discord bot talk to the service? So if I remember correctly, it's in the answer. So we had those slash commands. So if you wanted to run this, you type /ask. There's some nice features in Discord, like kind of arguments and documentation of those arguments. Where are we at? Yeah. Oh, it was runner, not answer. Runner. So, when you set up something as a web endpoint on Modal, you just have like normal HTTP access. So if this were a requests library, like if this were synchronous Python, we could just use the requests library, and this would look really simple. It would just be there'd be a GET request to a particular URL with certain parameters, but because it's async Python, everything has to be like async with, await, return. It's a bit clunky to write this stuff in my experience, but what you end up with is like you can write a pretty scalable web server in Python. That's an important point. Gradio provides these UIs. Underneath the hood is Fast API. So Fast API is one of the like more user-friendly ways to get like an asynchronous Python like web service running. If you wanted to go like another level down under Gradio, like you wanted to offer stuff where user interface didn't make as much sense, Fast API would be a way to do it. And I believe that's what's underneath this Discord bot as well. So that's just like jumping back to our diagram to make sure that where we're at is clear. So that's I was just showing the Discord bot server that's just like sitting on a little cloud instance on AWS. And the meat of the application is all the stuff running on Modal's infrastructure as these like little containers that get like spun up as needed to serve traffic.
What library did you use to generate embeddings?
Oh yeah. I guess I didn't call out the embeddings here. So OpenAI offers embeddings. They have like a bunch of additional embedding models that aren't good for like generating text, but they are good for like extracting the context of text and putting it into vectors. So it's the OpenAI ADA 002 model. It's like dirt cheap. It's like 100 times cheaper than the generation endpoints, maybe more. And it like gives decent results. I think it would be a good idea to add additional types of search here. Like right now, I just have data storage goes to a vector index, and that's the communication. I think really you want your data storage with your metadata there to like actually pull out the information, not just the embedding.
And people also ask about processing PDFs.
Yeah, so that one was primarily in the previous one. I actually don't have that code in this repo yet, but that one was, I believe I could just do this. Yeah, there we go. So the like core thing I was talking about in the morning was like write some local code that just talks about the like what is the high level thing I'm trying to do. I'm trying to use some like a description of some PDFs to get a hold of their URLs. I want to read all of them, and then I want to add them all to the document DB. The part where I spun up 100 containers, that was this map call here, which says like, which takes you take a function that you've defined in Modal and you map it over some iterator and like spin up. You can control the concurrency. I just said maximum concurrency for fun, but you can control the concurrency, how many things get launched to handle those, returns them in order, which is convenient. And then you get back something that's in your local Python. And you take that thing in your local Python, and then you can pass it back up to some Modal function. So with the application, the way I've set it up is really like web servicey. It's like there's a bunch of services, they have URLs, you talk to them. You can also run things that are in a much more Python-y way. Like it looks as though this is just normal Python, like I'm doing a map, I'm just like calling something, but really this is doing stuff via web services. But the serialization and deserialization is like kind of handled for me.
And you may have shown this, but what again is the retrieval, like how is the retrieval result put into the zero-shot prompt or put into the prompt?
That is actually inside the LangChain prompt template. So it's a little hard to pull it up. But the basic answer is that it's an F string. So you have a templated string. So you might be familiar with Jinja templates if you're more of a web developer person, and you just insert the things that come out, the sources into the prompt as like, this is the source, like brackets, the source URL, this is the content, brackets, content. And that all gets stuffed into the prompt.
Maybe just show the function if you have it here.
Yeah, it's deep inside of the LangChain library. That,
no, but like just what's the LangChain call?
Oh yeah, that's not super.
And then a good question is, what do you think are the top 3 challenges for you if you wanted to take the bot to like the next level?
Yeah. So this is to answer the previous question. It's like you provide a little dictionary with the stuff that needs to go into those into the components of your template, right? So this I'm calling a chain on LangChain, defined with LangChain, and it's this dictionary here that has input documents and a question, and this gets put into the prompt here. So not particularly like detailed on how that goes, but you just in general like hop onto LangChain's GitHub and like look up the source code. As something that's like mostly a framework, kind of like the Hugging Face Transformers library. It's something where the code is often like quite simple. It's just that you don't want to have to write that boilerplate. You want to use something that has an interface that other tools will expect, et cetera. So it's not super complicated. So I often find myself just like reading the code. Then the follow-up question was, what does it take to bring this bot to the next level? So I think the top 3 challenges, one is making sure, like improving the retrieval. The second one is improving the quality of the model outputs. And the third one would be actually, identifying a like solid user base. So the third one, that's too hard of a problem. Like, if this were actually a useful idea, I could, launch it as an independent startup. So I'll focus on the first 2. So for improving the retrieval, I think the primary thing is that people have been working on information retrieval. There's a bunch of ready to go ideas there. For improving the quality of the language models, I've made a little bit of progress in that direction. So one thing that has been added is information is logged to a feedback store or a place where all the behaviors of my model can be stored. So if you're familiar with tools like, even just like Datadog and Sentry, but also Honeycomb for handling a web service, you want to know everything that is going on in a web service. You want to know what the inputs and outputs were. And if you're in a distributed setting, it can often be like very difficult to debug stuff without that kind of that amount of tracing. And so the same principle applies with ML-powered apps and LLM-powered apps. You want to trace what is, what queries are coming in, what the answers are, and in this case. And so Gantry provides that for this. Let's see, where's my Gantry login code? Yeah, logs the events to Gantry. It's pretty straightforward. I log records. You want to keep track of a join key. Just to make sure that you have like a unique identifier for stuff in case you want to bring in, like there is that emoji feedback. That emoji feedback's not available at the time that the event is logged. So you want to have like a key so that you can pull that later. Maybe you run like a nightly or weekly job to like ingress that feedback and join it. So I think I'll close out then in our last 5 minutes with just like quickly showing what that looks like. So this interface here, like here's, this is just the high level dashboard showing like what happened today or in the last 24 hours on this application. So last night I was testing it pretty in the evening. Then this morning, put it out on the Discord. Looks like people used it a bunch. This afternoon, started talking about it again. People started using it again. So just like high level count of events. Then maybe one of the really useful features is I'm like at the moment that the event happens, I just want to like grab what happened and store it. But later, like the inputs and outputs are unstructured data. So there's lots of potential questions you might want to like ask about it. Was this an instance of my model being like biased? Do I have a user who's trying to hack my model? Like, do I have a sudden influx of users who speak a different language? And there's a nice Gantry feature for enriching data that you've already logged these projections. So for example, is somebody asking toxic questions? Oh yeah, this is a little small, sorry. Yeah. So you can add these afterwards, backfill them, and then they'll get filled in as you go. Some of them are like natural language-based things, like is this an insult or not? Some of them are more numerical things, like what's the entropy of this text? What's the number of sentences? There's projections for other things. There's some more advanced features like embeddings if you want to really get crazy. I was looking at some comparisons. For example, you can intentionally try and extract like what are the toxic questions and non-toxic questions. People seem to have behaved themselves pretty well this morning, and nobody really asked any toxic questions. So that's maybe good. But there was in here, this toxicity check did pull up this particular record where somebody asked about prompt injection and was like seemingly attempting to maybe prompt inject the model. So give an example, prompt injection that works on GPT 3.5. Yeah, nothing, in the last half hour before this talk, I went and checked and looked for any interesting patterns, and it looks like, there were some questions that the model didn't answer super well, but nothing too concerning on behavior of users or on behavior of models. But yeah, it's good to be able to like have that information to look into. And then you don't necessarily need to just analyze it in Gantry's interface. So you can actually like get that stuff back down. So I pulled it into a pandas data frame that I could check out on, just on my own. And the thing that I tried with my 10 minutes during the break was one of the most promising avenues for actually being able to check whether our applications work is using language models to check on our language models. So I was just like, hey, ChatGPT, is the answer below a reasonable answer to the question? If it's a reasonable answer, respond with yes. If it's an unreasonable answer, respond with no. Question, answer. Threw that up into into LangChain, ran the ChatGPT, the turbo model on it, and just like parse the answer. If yes is in the answer, then it's a reasonable answer, and tried it out. ChatGPT thought about half of the answers were reasonable, and we can see a couple of those examples here. So what does it think reasonable? How are you doing today? I'm doing well, thank you. Who's a good bot? A good bot is BlenderBot 3, a deployed conversational agent that continually learns to responsibly engage. So, I was hoping I would get like a magical moment with the LMs, but it's a little fiddly still. It would need some tuning on this data set to get it to work well. But yeah, in principle, you can like start to identify issues with your model by looking through data that you've logged, like it frequently, for example, this particular prop template contains the State of the Union address from 2020 in it, or 2021 in it, and so it tends to accidentally say things about Joe Biden, Justice Stephen Breyer, and the coronavirus pandemic. So like identifying that and like making sure and like checking for that in your outputs, very doable with language models, and then tracking it with something like Gantry. So that would be that's to wrap it back up to the original question. The real difficult thing is like determining whether the thing is running well in production, whether users are happy, and there's like tooling for observability for ML. That's probably the solution for that.
Have you welcome contributions?
Yeah. So it's open. I would like to make this better. I think we would like it to eventually develop into a teaching tool application, and so yeah, we'd love contributions. But yeah, I'm over my time, so can't take any more questions. Thanks, everybody.